Welcome back to Climate Unboxed. Today we're going to be discussing time. So here we have the arrow of time. Now, of course, we know we can't reverse the arrow of time. If we do this, what we're going to be doing today instead is we're going to be making calculations of statistics over time. So means, standard deviations, maximum and minimum of our data sets over specific periods such as daily means, monthly means, or annual means. So let's get to it, shall we? So let's say we want to calculate the annual averages from a data set like the one you can see right behind me. The data set behind me covers a total of 2 years and it has monthly data points. And we want to calculate the annual average. Therefore, we would want to calculate the average over time of the first 12 data points, shaded with green, and we'd have one value that marks the average over that period, marked by the dotted line. The second year, marked in the peach color, would then also have its own annual average. So we end up with 2 data points, one for year 1 and one for year 2. Well, you might say that's quite easy to do. It's simply the numerical average of the 12 data points. Yes. But now imagine that you had daily data as an input. Now things start to get complicated. Are one of the years, for example, a leap year? So it's much easier to do these things in CDO. So let's have a look at how we actually do that then. So the format of the command is CDO, and then we have time period and statistic. And then of course, input file, output file. So I'm going to consider this in turn. The time period statistic is a function that's made up of 2 components. The first, highlighted in red, is the time period. Now in CDO, we can do averages and functions over all sorts of time periods, which are shown here. So in the list, time refers to all of the time steps in the input file. And then we have year functions over seasons, months, days, hours, and there's also a running function where we can do running means or running max, but I'm not going to discuss that here. I'm going to leave that to a separate video, so for the moment I'm going to leave that out. Each of these has an abbreviation in CDO. Now in some cases the abbreviation is no shorter, day is simply day, hour is hour, that's easy to remember. Then for the other functions, time is normally abbreviated to TIM and seasonal to SEAS, month to MON, MON. So you'll need to remember these abbreviations, but they're very straightforward. Once we've done that and we have these abbreviations in mind, we need to now move to the second part of the function, which is the actual statistic that we want to calculate. Now, before we discuss that, I'm going to move myself over to the middle. Here we go. Because then you'll see on the other side, just over here, is appearing all of the functions that we can consider. So we have mean, average, sum, range, standard, var, min, and max. Now, standard is short for the standard deviation. Okay. Mean and average I'm going to talk about in a moment, what the difference between those two is. And then sum is the total over the period that we're considering, and then minimum and maximum are obvious as well. And lastly, range calculates the range over the time window of the variable in question. So now what we need to do is we have these 2 parts of the function, the time period over here and the function over here. And we want to put those together. So I've highlighted 2 examples, year and mean. We put them together and the function is simply year mean with no spaces once again. And so the complete command to calculate the average over the years will be CDO year mean input output. It's as simple as that. So I'm going to move myself back over out of the way here. And I want to discuss one other thing with you about calculating the averages. Now, this pertains to the timestamp. Now, we're calculating the average over a year. Now, what you could do is you could allocate the timestamp in the file to the midpoint, which is highlighted here. But you could equally actually allocate the time at the beginning. You could put 1st of January, or indeed the time at the end of the year, 31st of December. All of these would be valid choices for a timestamp associated with that yearly average. CDO allows you to specify this using the option timestat_date. And so this would be specified by timestat_date middle. There's also a mid-high that basically gives you the choice between the 1st of June or the 16th of June. Now, middle is actually the default option, so if you don't specify this option, you will have the timestamp in the middle of the year. Now, the other possibilities is to actually label the beginning, which is timestamp_date first, or you can also simply specify it to last, which allocates the end of the year as the timestamp. So we can see this in use here with CDO --timestamp date last. Then we have the function year mean and then input output. And again, to emphasize, we need a double hyphen in front of the option here. So now we can combine any of these functions together very simply. So you could put mon together with max to find the maximum over the month. Now, I mentioned earlier there were two functions that sound very similar, mean and average. Now, what is the difference between those two?
So this video was getting too long, so I decided to explain this topic in a separate Climate Unbox short, which you can view by clicking the pop-out banner right above my head now.
Now, the next topic I want to talk about is instantaneous field versus fluxes. So on the Era 5 menu, there are lots of variables. This is just a subset of examples which are essentially stored as instantaneous values: clouds, temperatures, winds, humidities. Each of these, when you have a value at a certain time, is like a photograph, a snapshot. Now, if you think about it for a second, if you have a snapshot, let's imagine here we have some artificial hourly data that covers a period of 2 days. And so one of these data points here is actually at midnight between the 2 days. And so I can ask you a question: where does the midnight value belong? Does it belong to day 1 or does it not belong to day 2? Now, in fact, there's no correct answer to this question. It's precisely at midnight. You could allocate it to day 1 or day 2 by choice. Now, by convention, usually midnight values are allocated to the following day, and that's the convention that's also adopted by CDO. So if we take a daily average, it will average the 24 hourly points that go from midnight until 2300 of that particular day. So the midnight value is included in the average for the following day. Now that becomes important when we consider flux fields. So flux fields are fields such as precipitation, radiative fluxes, or latent and sensible heat fluxes, as an example. Now, why are these called flux fields? Now, let's think about it for a moment. Precipitation, we could go outside and measure the rain rate right now, but maybe in 10 minutes' time the rain would have stopped or intensified. So if we take a snapshot at any particular time and then use that to say, well, the average over the hour is just that snapshot scaled up for the hour, we could have very incorrect results. So any kind of flux for energy or water needs to be accumulated over a period of time. Now I can illustrate this now with a very simple cartoon. Let's imagine we have a bucket, it's 3 o'clock in the afternoon, and then a cloud appears above our bucket, that's over our grid cell, and it starts to rain. So we can record the amount of rain over the period of time. And so we can see that this value at 4 p.m. is actually the total over the hourly window from 3 p.m. until 4 p.m. Of course, it depends on your accumulation time. So now, again, it becomes an issue when we actually have to allocate a timestamp. We could allocate a timestamp at the beginning of the window, the middle of the window, or indeed at the end of the window for this particular accumulated value. So here we have, by default, in Era 5, the timestamp is actually allocated at the end of the window. In other words, the value when you download rainfall at 4 p.m. and its hourly data is the hourly accumulation from 3 p.m. until 4 p.m. stored at 4 p.m. I hope that's clear. Now this can cause some issues when we want to do daily or monthly or yearly averages. So the issue is that when we're looking at accumulated fluxes, the timestamp at 11 p.m. is the rainfall from 10 until 11 p.m. That's fine. But the problem comes when we actually look at the next time slot, which has the timestamp of midnight. Now that is the total from 11 p.m. until 12 p.m. And if you remember when we perform the day mean or a day sum, the midnight timestamp is included in the following day. That means when we do day sum, we're actually picking up the last hour of the day before, and we're actually missing the last hour of the day in question. Now, how do we get around that? Well, what we actually want as our solution is we want the midnight timestamp to refer to the accumulation over the following hour from midnight until 1 a.m. Now there's a command, so what we want to do is shift the time all the way over to the start of the slot. Now I'm going to reduce myself so you can see the command below. It's shift time, CDO shift time, and then you specify the units, which are hours. So we have -1 hour, then we have the input file and the output file. If we do that prior to making the day sum or the day average, we are now going to pick up exactly the right time slots for the daily average. So let's see this in action. What I've got open behind me now is the interface again for the ERA 5 data. It's the hourly data on single levels from 1979 until the present. And if we scroll down, I'm going to show you the issue that arises. So we've got reanalysis selected and total precipitation. And then we scroll down to the dates. Now I've just picked 1 year as an example, 2019. Let's say we wanted to get the daily or hourly data over the month of August. So we would click here on August, and then we would say, okay, let's take all of the days and all of the hours. But of course we've got a problem because of this shifting in time. In fact, the first day of August, midnight, actually is the rainfall from the last hour of July. And the very last hour of August is actually missing. And so we can see that we actually have to get the month of September as well in order to have the whole month of August values. So now if we go to the bottom and we click on the API request, this is the request, and I'm going to cut and paste that into a Python file as I've showed before, and we will download it. So here in this directory, we have the file we've just downloaded. If I open it up in NC View, here we go, and we have the precipitation in the file. Now, normally when you look at the precipitation values, mostly they are very small, and so the range is dominated by the large values. Let me change the color scale. It's usually a good idea to actually change the option linear to low, and then you can see the smaller values much more easily. Now, if I run this forward, we can see this beautiful animation of the precipitation for the 2 months from the reanalysis data. So let me quit this. We can actually look at the dates in the file using CDO show date and the name of the file. And the first date is the 1st of August and the last date is the last day of September. And remember, the values are actually the hourly values, so I can say CDO show time, and now we see that the timestamps basically increase 1 hour at a time. So what I want to do now is calculate the daily values, and the daily values, in order to do that, we need to shift the time first. So I'm going to do CDO shift time, comma, -1 hour, and then precip, and I'm going to call it shift. And there we see the shift time has taken 31 seconds to operate because it's a very large global file at the full resolution. And now we can do CDO day sum. But before we do that, let's just have a look at the time stamp and the day stamp. So now I'm going to use CDO show date on the new file. And look what's happened. The first date is actually the 31st of July, because what we've done is we've shifted the timestamp 1 hour earlier. So instead of the very first timestamp being midnight on the 1st of August, it's now 2300 for the 31st of July. So that first timestamp, when we do the day averages, will actually be allocated now to the last day of July, which is actually the day it pertains to. So now we can do CDO day sum, and the input file is precip shift, and then precip, I'm going to call it total. And we have a problem here for the day sum, which we've seen a couple of times. This will sometimes occur because the data is compacted, and so we need to unpack it using this option -b F32. So I'm going to add this -b F32. Okay, and we see that the file has now been processed. If we look at the sizes of the files, we have precip, precip shift, and precip total. And precip total, you can see, is around 24 times smaller, which is what we expect because we've calculated the sum over the whole days. So now when we open up this precip total, we now should have daily values. Let's make this load like this. Now, if you remember, we wanted the whole of August. If I do CDO show date precip total.nc, we actually have a file that has 1 day in July, and it's not even a total daily sum because we only had 1 hourly time step. So we really want to get rid of that and cut that off. And we've also got all of the September days. So if we only want to keep August, we need to do a selection of the time. Now there are several ways we can do this. We can do CDO cell date, and then we actually specify the start and the end date. So we have CDO, and then we can say 0801, 2019, 0831. Precip total, and then precip August. Another option would be to actually just use the cell mun. So we can say cell mun, comma, and we need an option. So I'm going to select the 8th month for August, and I'm going to call this August 2. And if you can see, these two files are actually almost identical. The only difference will be in the size of the metadata. And if I do now CDO show date on either of these, hopefully we should only get the days for August. And that's precisely what we have. So you can see that we have 3 steps that we had to do. We had to do number 1, we had to shift the time back 1 hour. Number 2, we did the daily sum. And number 3, we needed to then select the dates of the data that we actually wanted to have. So in this case, that was for August. So we saw today how it's very easy to calculate statistics as a function of time using climate data operators, means over days, over months, seasons, or even years. So I hope you found the video very useful for your work, and I look forward to seeing you again another time. And don't forget,